So now we are going to talk about a very important name reaction, which is Fisher-Indole Synthesis. In fact, this reaction was developed in 1883, or this is one of the most important reactions to synthesize the pyrroles. So इसी से evident है. Now we are going to be talking about the chemistry of the pyrroles and what are the methods that are used to synthesize this pyrrole moiety. जैसे कि मैंने बोला, Fisher he developed this method in 1883. You can imagine almost कितने 150 साल हो गए इस method को, and still इसके इतने सारे variations आज भी known है, and people have been employing these reactions to synthesize this indazole coat. So इस reaction के अंदर what happens basically? What do? We take phenylhydrazine and aldehyde or a ketone. That's what we do. We just take them together and we heat it in presence of a Lewis acid. So it can be in presence of an acid. So this can be a normal acid. जैसे कई reactions होंगे आपने देखा होगा H3PO4 H2SO4 में भी, जैसे यहाँ की acetic acid में भी, और Lewis acid जैसे जिंक क्लोराइड हो गया या BF3 हो गया, उन मीडियाज के अंदर भी रिपोर्टेड है. सो इसके काफी सारे वेरिएंट नोन है. तो अगर इसका जनरल रिप्रेजेंटेटिव दिखाऊं रिएक्शन का, सो व्हाट यू हैव इज अ फिनाइलहाइड्राजीन and you have is a symmetrical ketone. इस केस में symmetrical we have taken cyclohexanone and this is the indole that we get. इसका मैकेनिज्म हम समझने की कोशिश करेंगे आज. अगर इसका हमने मैकेनिज्म एक बार समझ लिया तो I think we'll be able to crack almost any problem that is based on the indole synthesis. And we are also going to look at what is the driving force for this reaction, which factors makes this particular reaction to go in the forward direction. ठीक है, let's jump into it. So the first step is usual. हमें पता है कि when we mix a hydrazine with a ketone or aldehyde, the first step is the formation of a hydrazone. इस केस में this can also be called as an imine. ठीक है, क्योंकि जब हम दोनों को mix करते हैं, during the process the water is released. So what we get is from hydrazine we get the hydrazone. Hydrazone अब हम इसका क्या लिख सकते हैं? Tautomer लिख सकते हैं. इसका दूसरा tautomeric structure क्या हो सकता है? When this hydrogen shifts here, this comes here. So if this is a hydrazone, or we can call this as an imine. ठीक है. So the other tautomer is an enamine. इसका दूसरा tautomer जो है वो है enamine के अंदर. So these reactions are going forward under thermodynamic. So this is thermodynamically controlled product. ठीक है. Under these reactions, this enamine undergoes becomes enamine. और जब as soon as this becomes enamine, this is the most important step it undergoes. It undergoes 3,3 sigmatopic rearrangement. जैसे कि हमने बोला कि 3,3 sigmatopic rearrangement के अंदर 3 एटम इन्वॉल्व होते हैं either side, और एक सिग्मा बॉन्ड आपका टूट रहा होता है, एक सिग्मा बॉन्ड आपका बन रहा होता है. जैसे फॉर एग्जांपल इन दिस केस व्हाट इज हैपनिंग, ये बॉन्ड यहां शिफ्ट हुआ, ये इधर शिफ्ट हुआ, ये इधर शिफ्ट हुआ. सो इफ वी हैव 1 2 3 एटम हियर, we have 1 2 3 atom here. So this is 3 sigmatropic because it's a sigma bond. Here this sigma bond is breaking and here a new sigma bond. This is the new sigma bond that has formed. That is the 3 sigmatopic bond. Now what is the driving force for this particular reaction? This reaction the driving force क्या है? The driving force is that at the expense of this weak nitrogen bond, what we are forming is a strong carbon-carbon bond, right? So that drives the reaction into the forward direction. इसी वजह से reaction होता है. That is the reason why this 3,3 thermodynamic sigmatopic rearrangement take place. And remember, we are heating these molecules, so we are providing them with enough energy to undergo this transformation. ठीक है? So what is the driving force? अगर कोई भी अगर आपसे इंटरव्यू में पूछे, कहीं भी पूछे, you should remember this, that it is this stability, it is this formation of strong carbon bond at the expense of weak nitrogen bond. ठीक है, यहां ब्रेक हुआ, ये फॉर्म हुआ. So once we have this, it is pretty straightforward यहां से. So this comes back to form the amine because of the aromatize, and then as soon as the amine is formed, it attacks this carbon because होता क्या है, at the expense this is getting protonated. Protonation होने की वजह से this is becoming electron deficient. So that is why the attack takes place. So what you form is basically this aminal. अब आपके aminal क्या होते हैं? Aminal is nothing but it's a nitrogen equivalent of acetal. जैसे कि आप ये देख लीजिए, हमें पता है कि this is acetal, right? हमें पता है this can also be written like this one, aldehyde and OH, इस तरह से, राइट? इसको अगर हम इसका एसिडल प्रोटेक्शन करेंगे, एसिटल करेंगे, इसके अंदर हम एसिड डाल देंगे, we are going to get the acetal. This is exactly what is happening. So these aminals are nitrogen equivalent of acetals. That's exactly what is happening. So next step is the protonation of the amine. So this amine gets protonated, and then in the next step this comes back, ammonia is kicked out of the system, and in the next step this proton comes, it is released to give you the final product. So जो सबसे important step अगर जो आपको हमेशा याद रखना है, वो आपको मैं हमेशा बोलता हूँ कि ये स्टेप याद रखना है कि that the formation of enamine and 3,3 sigma topic arrangement. This is the most important step that you have to remember. कि आपको हमेशा enamine बनाना है, enamine के बाद ही ये sigma topic arrangement होगा. If you do that, you will be able to solve every problem that is based on this chemistry, that is based on Fisher-Indole synthesis. अब जहां तक अब देखो, so here what we started with basically a symmetrical कीटोन, मतलब यहाँ पर आपको अगर इनोलाइजेशन हो रहा है, मतलब here what you are doing is basically you are making this enamine. अगर ये अनसिमेट्रिकल होता, दूसरे ऑप्शंस होते, ठीक है? इन दैट केस you might end up getting a mixture. वो हम चीजें देखेंगे कि क्या क्या रिक्वायरमेंट है to get a single product. Similarly, in the case of phenyl hydrazone, this is unsubstituted hydrazine, right? आपका अगर यहाँ substitution होगा, as long as you have substitution at this position, you are going to get single product. But if you have substitution at other positions, you will get a mixture of product. So now we are going to look at the examples. कि हम देख लेते हैं किस किस केस में symmetrical मिलेगा, किस किस केस में unsymmetrical मिलेगा, ठीक है? So for example, अगर आप देख लीजिए ये वाला नॉर्मल अगर हम एल्डिहाइड लेते हैं, एल्डिहाइड का फिनाइल हाइड्राजीन के साथ रिएक्शन होगा. So this is the only hydrazone that you can get. So this can only enolize, मतलब ये केवल इसी पोजीशन पे enolize हो सकता है. So there is just no other possibility. So you can easily form 3 substituted indoles in the case of the aldehydes. But let us suppose this particular hydrazine, this ortho position is blocked. ये position blocked हो गई. So the only place where the reaction can take place is here. So with such compounds, you will get the single product. So you get the single product because it's here. The other part that you are taking is also symmetrical. What about this compound? अब इस वाले पैरामिथॉक्सीफिनाइल हाइड्राजीन के लिए these two positions are the same. So basically what you are doing, you are driving this reaction to give you the single product. Similarly, आप दूसरा वेरिएशन कर सकते हैं. You can start from the phenyl hydrazine and then take a symmetrical ketone to give you a single product. Now, you could be asked a question. Let us suppose if I start with the phenyl hydrazine, this one. Suppose if I have phenyl hydrazine and if I have substitution at this position, then you are going to get a mixture of product. Let us suppose अगर मैं यहाँ पे ओमिथॉक्सी रख दूं, तो you are going to get a mixture of product because तब आपका क्या हो सकता है, यहाँ पे भी इधर से भी साइक्लाइजेशन हो सकता है और इधर से भी साइक्लाइजेशन हो सकता है. इधर साइक्लाइज होगा तो आपका मिथॉक्सी ग्रुप यहाँ है, इधर साइक्लाइज होगा तो आपका मिथॉक्सी क्या है, मेटा है. You are going to get the mixture of products. So just keep in mind. Similarly, if you let us suppose if I have a cyclohexanone, अगर मैं cyclohexanone में यहाँ पे मिथाइल ग्रुप लगा दूं, I am going to get a mixture of product. If I am going to have a substitution here, I am going to have a mixture of product. Similarly, if you start from unsymmetrical ketones, then you are going to get a mixture of product. And if you are going to start from phenyl hydrazine having substitution at 3 position, you are going to get a mixture of product. So just keep these things in mind. Now we are going to look at the synthesis of Sumatriptan, which is a drug which is used for the treatment of migraine. So the synthesis basically starts from this aromatic amine having this sulfone group. Okay, so it has this sulfone group in it. Now the first step is basically NaNO2HCl. So what we are forming is this diazonium salt here. So this is what we are forming here. And in the second step we are doing SnCl to HCl. So basically what we are doing, carrying out the reduction of this diazo into an amine. This is exactly what we are doing. We are reducing this into an amine. So what we are forming basically in this 2-step protocol is a phenyl hydrazine. That's what we are forming. Since we are using acidic condition, that is the reason why what we end up getting is the HCl salt of this phenyl hydrazine. ठीक है, ये protocol हो रहा है. Now the other substrate that we are taking, क्योंकि हमारे पास हाइड्रोजीन तो हो गया, now what we need is either ketone or the aldehyde to carry out the Fisher-Indole synthesis. So this is the Fisher-Indole synthesis that we are carrying out now. Basically what they have taken 3-cyanopropanol. Propanol का जो किया है एसिटल लिया है, ठीक है. This is nothing but the acetal of 3-cyanopropanol. उसका रीजन क्या है? अगर ये इसकी जगह ये लेते, let us suppose had they taken this one aldehyde. So this aldehyde has the propensity to undergo self-dimerization. So this is not a good alternative to take. So instead of the aldehyde, they have taken the acetal of aldehyde. So जब हम उसका रिएक्शन करते हैं फिनाइल हाइड्रोजीन के साथ, what we get is the imine formation. So okay, imine formation, and this is nothing but this is pyrophosphoric acid. So this is one of the acids. So as soon as this is exposed to the acid, which is this hydrazone हमें पता है कि this will be converted into the enamine and undergoing Fisher-Indole synthesis to give us the desired indole. Next step क्या है कि उन्होंने साइनो को reduce किया using H2 rhodium as a catalyst to give us the amine. Now amine को अब उन्होंने क्या किया is basically they carried out the dimethylation using a name reaction which is called the Eschweiler-Clarke reaction. So इसके लिए जो reagent that we used are formaldehyde and formic acid. So this is a very important reaction जो आपको याद होनी चाहिए. This could be asked. This is a very important reaction that you should know. So हमको पता है कि when we treat amine with formaldehyde, what we are basically going to form is an imine. Water is evacuated out of the reaction. This is formaldehyde. So we have this imine, and we are taking formic acid in the reaction. Reaction में आपका क्या है? Formic acid है. So this nitrogen non-proof electron, it is going to pick up this proton. This is released. So we have NH positive, CH2 minus. So next step में what you have is this. ये आपका जो format anion है, this is going to attack and it is going to be released. Now what you have is R, NH, CH2, and you have this oxygen here, and this is this. Okay. Reaction का driving force क्या है? Is basically the CO2 is released. So this is going to come here, and this is going to go. So the carbon dioxide is released out of the system. So what you have is RNH, CH3. Same cycle. Again, आपका क्या होगा कि since NH है, it is going to form imine. Same cycle is going to repeat to give you the NN dimethyl. So that's, if you want to do the dimethylation of amine, this is one of the protocols that you can use, formaldehyde and formic acid. So this is how the Fisher-Indole synthesis can be utilized. You can see how elegantly that chemistry had been utilized for the synthesis of the migraine drug. So now we are going to look at one more molecule where Fisher-Indole synthesis has been utilized. This is a drug molecule. So the drug molecule that we are talking about is Ondansetron, which is an anti-nausea drug. Okay, so this is the structure of the drug. So if we carefully look at this molecule, what we have is a 1-2-3 arrangement. We can clearly install this bond if we carry out a disconnection at here. So this entire moiety can be installed by the Manich reaction. So the easiest compound that we can have is this one. And we know such indoles can be synthesized by carrying out the Fisher-Indole between a phenylhydrazine and 1,3-diketocyclohexanone. इसके ऊपर अब हम इसका थोड़ी कुछ इंटरेस्टिंग चीज देखेंगे, ठीक है. फॉर एग्जांपल जो फर्स्ट स्टेप हमारा क्या है, व्हेन वी आर गोइंग टू मिक्स द फिनाइलहाइड्राजीन विद 1,3-डाइकीटो, या तो हमारा इमीन इधर बनेगा या इधर इमीन इधर बनेगा अगर इफ वी आर टेकिंग 1-to-1 इक्विवेलेंट, ठीक है. सो दिस इज द इमीन दैट वी आर गोइंग टू फॉर्म. So this is the imine that we form, and this can enolize, this can undergo enolize to give us the enamine. So this is the other tautomer, enamine. Now अब आपका question जो कि ये भी हो सकता है कि since here it is, there can be a formation of compound like this as well, right? Enamine जो बन रहा है आपका, it can form this enamine as well. So you have this. So just a second. Instead of enamine forming at this position, because what I am showing that this comes here, it comes here, it can be this hydrogen as well. So अगर ये वाला hydrogen हमारा इधर आएगा और to give us the tautomer, so it can arise this as well. क्योंकि मैंने आपको बोला था in this entire sequence for the Fisher-Indole synthesis, it is a thermodynamically driven process. Let's look at the stability of this one and these enamine. For this enamine, if we look at the conjugation, in terms of conjugation, these nitrogen के lone pair of electron are conjugate. So this extended conjugation brings extra stability to this enamine. जबकि यहाँ पर हमारा क्या है कि there's nothing, there's no, there is a conjugation between this nitrogen and this double bond. जबकि यहाँ पर क्या है, is this extended overlap, जो पूरा का पूरा conjugation हो रहा है, जिसकी वजह से this enamine is formed and not this one under the given set of conditions. Now हमारा जैसे ये imine equilibrates to this enamine and it is exposed to Lewis acid, that is zinc chloride. So it undergoes Fisher-Indole synthesis to give us the desired indole. उसके बाद to put the methyl group, simply potassium carbonate से आपने ट्रीट किया, बेस से ट्रीट किया, मिथाइल को हटाया to give the n-methylation. हमको पता है these are clearly the condition for the Manich reaction, that is the reaction of dimethylamine and formaldehyde. वो अगर यहाँ पर आएगा तो हमको पता है, but we can introduce this basically this one. It introduced n-dimethyl group. अब हमारा जो नेक्स्ट स्टेप ऑफ मिथाइलेशन उन्होंने क्यों किया, टू मेक दिस इनटू अ गुड लीविंग ग्रुप. अगर हमारा क्या है कि दोबारा से मिथाइल हाइड्राइड डालेंगे तो हमको पता है कि दिस कैन फॉर्म द क्वाटरनरी सॉल्ट, और वंस दे फॉर्म द क्वाटरनरी सॉल्ट दिस कार्बन बिकम्स अ वेरी वेरी गुड लीविंग ग्रुप अगर हम किसी भी न्यूक्लियोफाइल से ट्रीट करेंगे. सो नाउ टू इंस्टॉल दिस पर्टिकुलर मॉइटी, सिंपली इन दोनों को रिएक्ट करवाया, दिस कम्स हियर and it is going to attack here to replace it, and it gives us the final desired product. So that is how we can utilize the knowledge of Fisher-Indole synthesis to synthesize the various important molecules. So Fisher-Indole synthesis can also be utilized for the synthesis of Indomethacin. ठीक है, इसके synthesis के लिए भी we can use it. So here what we have is an indole molecule. Again, if we carry out a disconnect between carbon-nitrogen bond, so this is an amide bond. We can clearly form this by an EDCI coupling, peptide coupling, or by treatment with the acid chloride. So we can have an acid chloride and we can have a free amine. Now, this is a symmetrical structure, right? And we know such symmetrical, this is a symmetrical structure. We can see, यहाँ पे पैरामिथॉक्सी हमारा इस पोजीशन के ऊपर है, मैंने बोला था. So इसको हम आराम से सिंथेसाइज कर सकते हैं, ठीक है, ये हमारा सिमेट्रिकल है, दिस इज अवर सिमेट्रिकल. और जब यहाँ पर भी हमारा इनॉल बनेगा या फिर हमारा इनामीन बनेगा, इट इज गोइंग टू बी फॉर्मिंग एट दिस पर्टिकुलर साइट, मतलब मोर सब्स्टिट्यूटेड पे. सो दिस पर्टिकुलर मॉलिक्यूल इज अ परफेक्ट कैंडिडेट फॉर द फिशर-इंडोल सिंथेसिस. ठीक है, इसमें कोई भी हमें मिक्सचर नहीं मिलेगा, बट द ओनली थिंग दैट वी कैन डू, दिस एसिड कैन बी प्रोटेक्टेड एज अ टर्शियरी ब्यूटाइल एस्टर. उसका रीजन क्या है, व्हाई डिड दे प्रोटेक्टेड एज अ टर्शियरी ब्यूटाइल एस्टर? उसका रीजन ये है बिकॉज वी कैरी आउट Fisher-Indole synthesis अंडर एसिडिक कंडीशन, राइट? और अंडर एसिडिक कंडीशन हमारा क्या है कि दूसरे फंक्शनल ग्रुप, लेट्स से अगर मिथिल एस्टर हो गई, इथाइल एस्टर, दे माइट अंडरगो हाइड्रोलिसिस, उनका हाइड्रोलिसिस हो सकता है. टर्शियरी ब्यूटाइल एस्टर्स आर मच मोर resistant to the hydrolysis. So that is the reason why they decided to go ahead with that. So what we start with is a para-methoxy phenylhydrazine and a ketone where carboxylic acid is protected as a tertiary butyl ester. So the first step is pretty straightforward, is the formation of an imine. Imine हमारा फॉर्म होगा, उसके बाद नेक्स्ट स्टेप हमको पता है इनामीन है. इनामीन फॉर्म होने की पॉसिबिलिटीज कहाँ है, वन फ्रॉम हियर एंड वन फ्रॉम हियर. वी क्लियरली नो, तक तो जो कि मैंने समझाया है कि इट इज ऑलवेज गोइंग टू गिव यू दी मोर सब्स्टिट्यूटेड, जो कि थर्मोडायनामिकली स्टेबल है. ठीक है, मोर सब्स्टिट्यूटेड इज गोइंग टू बी फ्रॉम दिस साइड, एंड व्हेन यू एक्सपोज इट टू द HCl ethanol, it undergoes Fisher-Indole. It undergoes Fisher-Indole to install the desired moiety. ठीक है, नेक्स्ट स्टेप में अब आप क्या कर रहे हो, इज बेसिकली यू कैरिंग आउट द एसाइलेशन टू फॉर्म द अमाइड बॉन्ड इन प्रेजेंस ऑफ अ बेस. एंड इट सीम्स व्हेन यू आर हीटिंग दिस मॉलिक्यूल एट 210 डिग्रीज, जब आप इसको काफी बहुत ज्यादा ये हार्श कंडीशन, एंड व्हेन यू आर हीटिंग इट टू दैट टेम्परेचर, इट सीम्स दैट tertiary butyl ester is getting cleaved under those conditions to give you the final product. So that is how we have seen how useful this particular reaction is. So now we are going to talk about yet another method which is called the Reissert-Indole synthesis method. So this method in the basically what do? We start from 2-nitrotoluene. So that is very important. Having a methyl group ortho to nitro is the main feature of this particular reaction. So this, I think, based on this chemistry, the questions has already been asked in the NET exam. So what do? Basically, we start from 2-nitrotoluene and we carry out the reaction with diethyl oxalate in presence of a base. So here is it could be sodium methoxide. एक चीज हमेशा याद रखना, since you are taking an ethyl ester, so the base has to be ethoxide. अगर आप यहाँ methyl ester ले लेते हो तो यहाँ पर methoxide base होता, just to make sure that there is no trans esterification that is happening in the reaction. उसका ये reason होता है. So having this nitro group, what it does is basically, because of its minus I effect, because of its ability to withdraw electron from the ring, it makes this proton pretty acidic. उसकी वजह से ही although sodium methoxide is reasonably okay base, it is able to abstract this proton. अब जो वो proton abstract करता है, so this comes here, it comes here, comes here. So this is formed. Now what we have is a diethyl oxalate. This comes, it comes, and it is going to react here, it will go, it will come back, and ethoxide will leave. So what you form is basically this one. Now, what you do is basically you are reducing the nitro into an amine using H2 platinum as a catalyst and acetic acid डाल के इसके अंदर, ठीक है? So this is formed. As soon as this is formed, it is going to attack this ketone. Why ketone को? Because this is become very electrophilic, because what we have is an electron withdrawing ester group here, as a result of which this carbon becomes very electrophilic, this carbonyl carbon. So ये आपका reaction हुआ यहाँ पर, reaction होने के बाद this comes and the dehydration gives you the desired indole molecule. Now एक चीज बहुत important है, यहाँ पर you can do the hydrolysis and decarboxylation, so you can convert this into a normal indole. ये एक्चुअली बुक के अंदर हैज नॉट बीन शोन, बट अगर आपको यहां पर उन्होंने बेसिक कंडीशन दी होती टू हाइड्रोलिसिस एंड देन एसिडिक कंडीशन, क्लियरली टू पोजीशन ऑफ इंडोल जस्ट लाइक in the case of the pyros, they undergo decarboxylation very smoothly, so you can directly form the pyron from this one as well, ठीक है ये चीज. Now how this chemistry can be utilized? So let us suppose if we start from a symmetrical if we start from 1,4-dimethyl benzene, ठीक है, 1,4-dimethyl benzene से हमने start किया and we carry out a nitration. Obviously symmetrical structure है, nitration can be here, 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 it's all the same thing. So nitration gives you this desired product. So what you are forming is basically again 2-methyl नाइट्रो, ठीक है, दोनों के दोनों ऑर्थो पोजीशन पे हैं. सेम कंडीशन, दिस इज द इंटरमीडिएट दैट यू फॉर्म, अगेन द रिडक्शन कंडीशन टू गिव यू द डायरेक्टली फाइनल प्रोडक्ट. नाउ एक चीज अगर हम देखें, सो व्हाट डू वी हैव इज अ मिथाइल ग्रुप व्हिच इज एट पोजीशन 6. हमने देखा होगा कि यूजुअली व्हेनेवर यू वांट टू हैव अ फंक्शनल ग्रुप एट पोजीशन नंबर 6 इन इंडोल्स, it is the Reissert-Indole Synthesis that is favored, ठीक है. और अगर आपको 5 पोजीशन का सब्स्टिट्यूशन चाहिए तो Fisher-Indole Synthesis. ऐसा क्यों? क्योंकि हमको पता है इन द केस ऑफ Fisher-Indole Synthesis, अगर आपका सब्स्टिट्यूशन यहां होगा, ठीक है, जैसे मिथॉक्सी ले लिया आपने, only then you will get a single product. So basically what you are having is substitution at 5, जबकि Fisher-Indole में you can have substitution at 6 position. So depending upon कहां सब्स्टिट्यूशन चाहिए, अगर आपको रिंग पर सब्स्टिट्यूशन चाहिए, यू कैन चूज योर मेथड. सो दिस इज समथिंग दैट यू शुड कीप इन माइंड, ठीक है. उसके अलावा वेयर दिस सिंथेसिस स्ट्रेटजी हैज बीन यूटिलाइज्ड, लेट अस सपोज इफ वी हैव अगेन 2-methyl नाइट्रो, जस्ट मेक श्योर कि दोनों के दोनों एक दूसरे के ऑर्थो हैं, ओनली देन दिस रिएक्शन वर्क्स, कीप इन माइंड. सो what we are treating this is with the dimethyl acetal of DMF, so this is nothing but a source of formaldehyde और कुछ नहीं है. So what we are doing is basically a formylation reaction, that's what we are doing. So this is exactly what is happening. Methyl group हमने formyl group introduce किया, and then using iron sulfate in ammonium hydroxide we are carrying out the reduction of nitro to amine and in situ cyclization to give us the indole. Next step में हम क्या कर रहे हैं basically is the treatment with diazomethane to convert this acid into its ester. So we can clearly see how beautifully such name reactions have been utilized to form the important molecules having this pivotal indole architecture in it. So that is pretty much about it. Thanks a lot for watching the video. Have a good day.